In this session, let us learn about solving linear equations in one variable. Equation is a statement of equality of two expressions. So the power of the variable in a linear equation is 1. So the standard form or general form of a linear equation is ax plus b is equals to 0, where a and b are integers and a is not equal to 0. Here the power of the variable x is 1. And in every linear equation we have an equality sign. The part of the equation to the left is called as left hand side and abbreviated as LHS. The part of the equation to the right is called as right hand side and abbreviated as RHS. So in an equation, the value of the expressions on the LHS and RHS are equal. This is true only for a certain value of the variable. So that value of the variable is called solution of the equation. So let us take an example of a linear equation. 2x plus 3 is equals to 5. In this linear equation, LHS is 2x plus 3 and RHS is 5. So let us consider the value of the variable x as 1. Let us substitute in LHS the value of the variable x as 1. So we get 2x is 2 times of 1 plus 3. So on simplification we get 2 plus 3, that is 5. And in RHS we have 5. So therefore LHS is equal to RHS when the value of x is 1. So that means x is equal to 1 is the solution of the equation 2x plus 3 is equals to 5. So the method of finding the solution of an equation is called solving the equation. To solve the equation, we have two methods. First one is balancing method. Second one is transposition method. Let us solve few equations using both the methods. Consider the equation 2x plus 5 is equals to 9. In an equation, the value of the LHS is equal to RHS. To maintain the equality of LHS and RHS, we need to perform the mathematical operations by the same number on either side of the equation. So that means to isolate the variable x in the LHS, we need to subtract 5 on either side of the equation. Here we have 2x plus 5. So we need to subtract 5 on either side of the equation to balance. and maintain the equality of LHS and RHS. On simplification, plus 5 and minus 5 gets cancelled, and then we get 2x is equals to 9 minus 5 is 4. And for further simplifying, we divide by 2 on either side of the equation. Two gets cancelled, and then we get x as isolated in the LHS. 4 divided by 2 is 2. So therefore 2 is the solution of the equation. 2x plus 5 is equals to 9. Now consider another equation. Five x minus 10 is equals to 0. To isolate the variable in LHS, we need to add 10 on either side of the equation. Minus 10 and plus 10 gets cancelled by simplification, and we get 5x is equals to 0 plus 10 is nothing but 10. And for further isolating the variable, we need to divide on either side by 5. So 5 gets cancelled, and then x is equals to 10 divided by 5 is 2. So therefore 2 is the solution of the equation. Now the same equations let us solve using transposition method. Take the first equation. 2x plus 5 is equals to 9. To isolate the variable, we need to transpose the terms to the other side from LHS to RHS. So we need to transpose plus 5 from LHS to RHS. When transposing a term from LHS to RHS, its sign will change. Plus 5 becomes as minus sign. So on simplification, we get 2x is equals to 9 minus 5 is 4. Now when we divide both sides by 2, we get 2 will get cancelled, and then x is equals to 4 divided by 2 is 2. And the second equation is 5x minus 10 is equals to 0. To isolate the variable in LHS, we need to transpose minus 10 from LHS to RHS. When minus 10 transposes to RHS, it becomes 0 plus 10. So on simplification, 5x is equals to 0 plus 10 is 10. And by dividing by 5 on either side of the equation, 5 gets cancelled, and then we get x is equals to 10 divided by 5 is 2. So in both the cases, we got solutions of the equations as same. This is how we can solve many varieties of equations using balancing method and transposition method. Let us solve another variety of equation in transposition method. Consider the equation 8y plus 1 is equals to 2y plus 7. So here we have two expressions on either side of the equation. So we have variable on either side of the equation. So to isolate the variable, we need to bring both the terms with the variable to LHS. So for that, we need to transpose the term with the variable in RHS to LHS. So here we have 2y in RHS, we need to transpose it to LHS, and when we are transposing, 2y becomes as minus 2y when it transposes to LHS. So we get 8y minus 2y. Similarly, plus 1, the constant term in LHS is transposes to RHS, then plus 1 becomes minus 1. So we already have 7 in RHS, then plus 1 becomes as minus 1 when it transposes from LHS to RHS. So on simplification, 8y minus 2y is 6y, 7 minus 1 is 6. To isolate the variable, we need to divide by 6 on either side. 6 gets cancelled in both LHS and RHS. So we get y is equals to 1. So 1 is the solution of the equation. Let us consider another equation. 4a plus 3 is equals to 2a plus 13. Here also we have variables on either side of the equation. So to isolate the variable, we need to first bring both the terms with the variables in LHS. We need to transpose 2a from RHS to LHS. When it transposes, it becomes minus 2a. Similarly, when constants are brought to RHS, plus 3 when it transposes from LHS to RHS, it becomes minus 3. On simplification, we get 4a minus 2a as 2a. 13 minus 3, we get 10. To isolate the variable a, we need to divide by 2 on either side. 2 gets cancelled, and then a is equals to 10 divided by 2, that is 5. So 5 is the solution of the equation. 4a plus 3 is equals to 2a plus 13. This is how we can solve many types of equations using balancing method and transposition method.